Welcome back. In our previous two hands-on activities, we created a rectangular brick and then we drilled 4 holes into its corners. Now, we need to create a post in the center of this brick. Let's do it. Now the first thing I'm going to do is throw in a twist. M. Night Shyamalan twist. And that is, we're not going to use the extrude tool. If that's the case, let's think back to our earlier discussion at the beginning of this module. What is a different way to create a three-dimensional shape that is not a linear extrusion? A revolve, right? What is the profile of a cylinder when it's revolved? It is a rectangle, right? The side view of a cylinder is a rectangle. So, let that inform our sketch selection. When we're asked to select a sketch plane, which one are we going to choose? Well, top isn't going to make any sense, right? Because if we lay a rectangle down on the top plane, there's no way that we can revolve it that will result in a cylinder sticking out of the top of our rectangle, right? So, we're stuck with either the front or the right plane. Dealer's choice, I'm going to choose the front plane. When we click on that, we're going to choose to change our view to normal to the sketch plane. And now, what is the shape that we need to draw? Yes, a rectangle. I'm going to choose a corner rectangle this time because I want to show you something. If I hover directly above the origin, not having clicked anything yet, you'll notice that there's this orange dotted line and this tiny little white box with a black vertical line in it. Interesting. If I move my mouse over here and I hover to the right or even to the left of the origin, you'll notice that that line in the little white box has laid flat on its side. And now if I hover directly over the origin, this icon changes to a little T. Do you recognize that? Aha! The coincident constraint. And in fact, the horizontal and vertical constraints. What this is saying is that if I were to click right now, which I will, and I start to draw my rectangle, when I drop the second corner of the rectangle, you'll notice that the left and bottom edges of the rectangle are already black. What does black mean? Well, it means that I can't move them. They're constrained, right? So the bottom and the left-hand side of the rectangle are fixed, while the right and the top edges of the rectangle are not constrained. What we just made was called an inferred constraint. The computer is inferring that by clicking where you clicked, i.e. on top of something, right, that you want it to create that constraint. This can be really helpful if you want to expedite this process, but you might find it very confusing if, let's say, we chose to draw a rectangle here and we wanted it to be, let's say our end goal is to draw one up here, right? But let's say our end goal is to draw a rectangle up here for some reason, right? But if I were to start my rectangle down here, well, now it's stuck to that edge, right? Because that inferred constraint of this point being horizontal with respect to the origin locked our block in place. So, this is to say that every click counts. When you're using CAD, you need to be very careful about where you place your things, anything, be they dimension bubbles or corners or points on a rectangle, right? Every click counts. If you see these little inferred constraint bubbles pop up, that means that you're going to be locked in there if you place your rectangle here. Alright, so we've created our rectangle. It is in line with the center line of our brick. Right? And so effectively what we need to do is we need to revolve this rectangle around this center axis. Right? And more so, since this plane is not an axis, and neither is the front plane, we're actually revolving around this left edge of the rectangle itself. Okay? Now what am I forgetting? Oh yes, dimensions, right? If I come down here and I click on dimensions, I'm just going to call this 0.75, and then I'm going to, well, let's see. I don't want to... Now that I look at this a little bit closer, I notice that my rectangle is overlapping the already constructed brick, right? So if we were to rotate this rectangle and revolve it around this left edge, we would get an overlapping section where these two rectangles meet. Ugh. Well, is that a problem? Well, let's think about it like a 3D printer, right? If our 3D printer was happily printing along, going back and forth, laying layer by layer by layer of plastic, and then it hits this, well, what is it going to do? It's going to make a double stuffed Oreo, right? It's going to try and print over itself. Well, no. Our 3D printers may not be smart, but our CAD is. Anytime Onshape detects an overlap in features, it's going to try to merge those features together. So let's actually create this dimension constraint. I want to create a constraint between the top edge of the rectangle and the top edge of the brick. When I click on this, I'm just going to call it 0.75 because I can. And now we're ready to revolve. We're going to come up here to this donut icon. And, ooh, interesting. You notice that I actually didn't press that green checkbox before. You can directly jump out of Sketch into Extrude or Revolve from Sketch mode. It's just a little shortcut. Okay? Now, it has automatically selected the sketch that I created. That's kind of an added bonus to choosing it directly from the sketch mode. So, now that we've selected our rectangle, you'll notice that there's a red section in our Revolve tool. This says the Revolve Axis. I need to select the axis to revolve around. In order to select it, I need to click on this red block, now changing it to blue, meaning that I'm about to make a selection, and I'm going to choose this line. Hey, look at that. When I click the green checkbox, everything looks great. We have our cylindrical post sticking out of the center of our brick with 4 holes drilled in it. Now, there's a likelihood that you may have accidentally found that your cylinder is actually offset, perhaps on one of the edges of this rectangle. What could have caused that, and how do we fix it? Well, instead of pressing Ctrl-Z over and over again, let's explore. If I go back to my rectangular sketch, which defines the cylinder, I can always reassign my sketch plane at will. If I had accidentally, when I first selected this sketch plane, selected the front edge of the rectangle rather than the front plane, which is in the center of the rectangle, you'll notice that it bumps my sketch out to this front edge. Now, the revolve still worked, which is pretty cool, but that's not what we wanted. So, if you fell into this trap, all you need to do, instead of starting over, is double-click on the sketch and redefine where that sketch is supposed to live. Great. Last thing, we almost forgot to name our sketches. All right, looking good. Now, when I showed you how that sketch moved out into the front on this front plane, you'll notice that I clicked on this little eyeball. And when I did, it made the sketch reappear. You may not have noticed this before, But when we first added our extrusions, after having made our sketches, the sketches will automatically be hidden. We can always undo this hiding function by clicking on this little eyeball tool next to each of our sketches. And in fact, we can re-hide them. And some other features may also have the ability to be hidden. The right plane, the front plane, the top plane, and the origin. When we hide that, now we have an unobstructed view of the beautiful creation that we've made. So, what's left? You may notice that the picture of our goal shows that there are some curved and sanded down edges to our part. Why would we do this? Well, I'll talk while we start to model, but to show you exactly what I'm going to do, I'm going to use this Fillet Tool and the Chamfer tool. Chamfers are flat edges, where fillets are rounded edges. Why would we do this? Well, one reason might be for looks, right? It's pretty. When we add this curved feature, it makes it look a little bit nicer, assuming that that's what we want. What's another reason? Well, if we were to make this block out of aluminum, you might notice that these sharp edges of the brick would be a great place to accidentally slide your hand across and cut yourself. So safety might be a factor in deciding to create chamfers and fillets. A couple more things might be that adding a fillet might allow for this post to slide into a socket a little bit easier. But one less obvious thing is the fact that a fillet actually adds strength to our part. If you've ever celebrated Thanksgiving, you may be familiar with the game played with the turkey wishbone. What happens when you pull on either side of the turkey wishbone? Well, it breaks near that point where the two edges meet. This is because the wishbone has a very sharp corner on the inside of it, and corners are where stress concentrates. Now, I'm not talking about stress like next week's physics exam kind of stress. I'm talking about the physical quantities of stress and strain. Stress and strain like to concentrate in corners. By filleting this edge, I've effectively created a more strengthened bond between the post and the brick itself. And that's it. Admire your work. You did a great job. I'm so proud of you. Now let's debrief.